Okay, today we're going to look at the first Pythagorean hyperbolic trig identity. Now, this is not the same thing as the Pythagorean trig identity because hyperbolic trig is not the same as just trig. What's the same is the relationship it has. The trig functions have the same relationship to the unit circle as the hyperbolic trig functions have to the hyperbola. So if you have a hyperbola right here, right? And say that you drew a line there. Now you don't really have a triangle here, but if you draw a line there, you have a triangle, and so we're still applying sort of the Pythagorean identity to this, even though there's not a triangle the way that there is with the trig identities. So excuse my notification sounds. I'm gonna turn that off. Okay, so what we're going to do is we're going to figure out what this equals. I'm going to tell you now it's going to equal 1, but you need to know why, because we're going to use this identity. We're going to use it to derive the inverse hyperbolic trig functions, and you need this for that. And you also, I don't think you need it to derive just hyperbolic trig functions, but inverse hyperbolic trig functions are a little bit trickier. So what are we going to do? I saw the way that you can do this, you can just roll it out because we know that hyperbolic sine is e to the x minus e to the negative x over 2, and hyperbolic cosine is e to the x plus e to the negative x over 2. You could just plug it in. It's a really boring exercise. A fellow student of mine in my Calculus 1 class had this genius idea. Well, I don't know how genius it is, but it felt pretty genius to me that you can just apply the difference of squares here. Because what this actually is hyperbolic cosine x plus hyperbolic sine x times hyperbolic cosine x minus hyperbolic sine x. And I'm going to do that. It's just a lot easier, really. It's just a lot faster. So I'm going to write that down. Why am I not getting changed colors here? That's why. Okay, so I'm going to write that down. So to solve that, we're going to get hyperbolic cosine x plus hyperbolic sine x times hyperbolic cosine x minus hyperbolic sine x. Okay, so what does that equal? Well, we're gonna plug in what we know hyperbolic sine and hyperbolic cosine equal. So we're gonna end up with, let me just, okay, we're gonna end up with e to the x plus e to the negative x over 2 plus e to the x minus e to the negative x over 2 times e to the x plus e to the negative x over 2 minus e to the x minus e to the negative x over 2. That's what we're going to have on the left side. I'm not going to reveal what we have on the right side till we've actually done the math, right? But, well, you know what? That's silly. We know it equals 1. What we're trying to do is prove it equals 1 by getting the left side to also equal 1, right? Okay, so now we're just going to, they have the same denominator, so we can rewrite this. We can rewrite this as e to the x plus e to the negative x plus e to the x minus e to the negative x times. Now, if you are confused, let me just write down that a squared minus b squared equals a plus b times a minus b. I'm not sure if you remember, but that is called the difference of squares. And you might want to refresh it because we forget things sometimes. So now on the right side of the, well, it's not on the right side of the equation, but the next argument we have is we're also going to have the denominator 2. So again, we're going to make this e to the x plus e to the negative x minus e to the x minus e to the negative x. close our bracket, equals 1. Okay, let's move over to the right side of the screen because it's getting a little bit crowded. So let's move over here. Now what do we have? Well, we can cancel out these right here because they eliminate themselves, right? E to the negative x minus e to the negative x is 0, right? And we can cancel out e to the x and minus e to the x. That's important. Well, what we end up with actually is 2e to the x over 2 times 2e to the negative x over 2 equals 1, which is interesting. And obviously we can get rid of these 2's. We can get rid of these, and we actually end up with e to the x times e to the negative x equals 1. Well, what do we know about exponents when we are multiplying the bases? We know that these get added, right? So what we actually have here is e to the x minus x equals 1. And what is x minus x? It's 0, which means we have e to the 0 equals 1, and anything to the 0 is 1. Therefore, 1 equals 1. So we have proven that this identity is hyperbolic cosine squared x minus hyperbolic sine squared x equals 1. Now, in the next video, I'm going to talk about how we can use this, what other identities come along with this, because just like with the Pythagorean trig, we can divide everything by cosine. We're going to get another identity. We can divide everything by sine, hyperbolic sine, and we're going to get another identity. So I'm going to do that in the next one. But for now, this is the first one, and this is going to help us to derive inverse hyperbolic trig functions.